Alright, okay, we have already introduced you the formulas of equation of straight line in three-dimensional space. In vector, given a vector equation, right, which is the formula. So in this video, we're going to give some examples in finding the equation of a straight line, which is r equals to a plus tv, where t is a parameter, right? It's a parameter. So as this will be the equation that we're going to use for vector for equation of straight line in three-dimensional spaces. So now you look at this, find the vector, parametric and Cartesian equation of the line passing through, right? Means that if there is a line passing through the point, this line is passing through a point, you have triplets with 2, 5, negative 1. This is already shown at x, y, z, right? Which is in three-dimensional places. And this line is in the direction. In the direction means they have a direction. The direction here will be I plus j minus with 2k. Or I can just rewrite this to be a column vector form. So 1, 1, negative 2. Right? 1, 1, negative 2. So, and this line is parallel to this direction or in the direction. And we have a point here. So, when I derive the formula for this, I have tell you that the formula, the r equals to a plus tv. A is a fixed point. Okay, it's a fixed point. It's a given point, right? It's a fixed point. So now, along this line, there is a fixed point on the line, which is 2, 5, negative 1, right? So I will usually let this to be a, my a. So I have to change the coordinate. I have to change the coordinate here. So into a vector form, right? Into position vector. So I have to change it, become a position vector. So 2i plus 5j minus k. Or I can rewrite this to be 2, 5, negative 1. This is the first thing, that you know the point, right? And this point on the line is your position vector of A. And the V is a direction, right? Any direction, right? As long as the direction of the line or any direction that are parallel to the line. Alright, for this case here, the V will be 1, 1, negative 2. Right? Because they already give you the direction. You must know the direction vector of the line. And this is a fixed point on the line. So once you know these two information, you can find the equation, which is r, the position vector of the line. It's the equation of the line. So the fixed point, which is 2, 5, negative 1. So I can rewrite it to be 2i plus 5j minus with k, right? 2i, 5j minus k plus with parameter t. Okay, later I tell you what is the meaning of t here. So the direction vector here will be I plus j minus with 2k. Then this equation, we name it to be the vector equation of this straight line. Alright? This is the vector equation in vector form, right? In vector form. Can you see that? All in vector form. So I also can rewrite this in the form of parametric. So actually the r here is refer. If you see that during my derivation just now, so the point r can be any point, right? It's a point r, can be x, y, z. It's a position vector for any point on the straight line, right? So I can rewrite r to be x, y, z, right? X, y, z, because x, y, and z, any point. So, and this you can rewrite as 2, 5, negative 1 plus with t, 1, 1, negative 2, all right? So I want to rewrite this vector equation in parametric form. I can compare x is the same as 2 plus t times 1. So means that x is 2 plus t times 1, which is t. Alright, so x in parametric form. So y, right? Y is the same as 5 plus t times 1. So which is 5 plus t. And z, z will be negative 1, right? Negative 1 plus with negative 2t, negative 2t. So this will be, all this will be named as a parametric equation, parametric form. So we say that parametric equation of the line, right? Parametric form. Okay, parametric equation of the line. And this will be a vector equation of the line, right? And lastly, you also need to know how to write the equation into a Cartesian form, alright? Cartesian equation. So let's see how to write in Cartesian equation. Right, let's see the Cartesian form. Cartesian form, I will use the parametric form. So which I want to eliminate the t. So very simple. So I have x equals to 2 plus t, as t can be rewrite as x minus 2 equals to t. Right? X minus 2 equals to t. And y minus 5 also t. Right? I can rearrange the parametric form with y minus 5 equals to t. And for this will be z plus 1 over negative 2. Z plus 1 over with negative 2 is equals to t. Right? So we have, if you see carefully, t in term of x minus 2, t in term of y minus 5, and t also can be write in term of x plus 1 over with negative 2. Since all these have the same, right, means that t, and t, so I can conclude that x minus 2 is the same as y minus 5. And y minus 5 is the same as, I can write the negative here to be bracket z plus 1 over with 2. This is the equation without the parameter. We name it to be a Cartesian equation. As you know that Cartesian is famous with xy, right? X, y, z. So now this is a Cartesian form, vector form, and parametric form of the representation, but all bring the same meaning. They represent the equation of the straight line in three-dimensional space. Alright, so I hope you understand. So we go for the next video for the next example.